Okay, I am so sorry. I just went through about 15, 20 minutes of prologue and you did not get my voice. I'm very sorry. Thank you, Teraflops, for pointing that out. Thank you very much. So, okay. Where was I? Okay, so we are searching. That was a big fail. This will teach me never to upgrade my operating system before a stream and then cut it so close. Okay, so the what I was saying while I was muted is that yes, I can zoom in. Here, we'll just bump up the text size. Hopefully that's better. Okay, so the common thing among these tests is the read side. They all are reading from a file that's already written. So what I'm looking for is where the bug entered as we added compression to the read side of things. So yeah, let's look at. So we were going through this. I was walking through this algorithm. It's basically, this is how you traverse the tree. You do an infinite loop until you either hit that there's no inner leaf, no inner node that indicates that the key exists in the file, or there's no or you reach a you reach a leaf node and then you try to find it among the keys in that leaf node. Obviously, this has the guard of if the Bloom filter does not contain the key, then you return immediately. So that's like the optimization, right, of the Bloom filter. Okay, so we need to look at how block does its entries. We changed a lot in here last time. And part of it was that we wanted to make it so that you could iterate through compressed blocks as transparently as uncompressed blocks. So we split this out. We have this from start length, and we did that a longer time ago. But we changed this up such that you note we weren't getting error incorrect block length. That's interesting to note. That's one thing that I suspected a moment ago might have been the bug, is that we introduced, oh, it's not computing the length of the block correctly, but that was not correct. We would have seen this error pop up in our tests, but we did not. Okay, so this is just reading the header of the block, determining the length, the level, and the compression. And then it is initializing the block struct with that information and the file. One thing we did here, which is probably, we need to read 7 bytes. This is reading 8. Maybe what we did was maybe we introduced like an offset error. Although this was working before with no compression, so but we did change this entries method, right? So we introduced the decompressor. Okay, so it's actually starting at the start plus 7 bytes. So that was, remember, the block length, the level, so that's 6 bytes, compression is 7 bytes. but it might need to start. No, it needs to start there. Okay, and then if the block length is 0, obviously it returns an empty, right? We know that start will be greater than end on this block contents reader, and so it will iterate through nothing. And then the attempt is to read the tag, so 1 byte, read exactly 1 byte. And if it's tag end, we return this. Okay, so we didn't get this error. We didn't get the incorrect size error. Now we need to look at if this is correct. So, right, so if we have reached the end of the block, so if our start offset exceeds or is equal to the end offset, then we can't read anymore. So we return, okay, 0. Then we seek to the start point. So if that is not the case, we seek to the start point. This is just making sure that our file pointer, its read pointer, is at the spot that we want to read from. And then we read into the buffer, and we look at the length. Right, so if it did read some, then we add that to the start. We add the length of that, how much it read, to the start, and then we return that. So this is really just our bookkeeping of, did we reach the end of the block? This used to be part of the entry iterator, but now the entry iterator is much simpler. It just takes something that implements a read. So this could be just a plain block contents reader. It could be one of the compressors, decompressor read implementations, and which means then the entry read only cares about this read thing. Okay. And then, of course, because this is an iterator, we just swallow anything not the best. Maybe we could put a little bit in here. Maybe we could have it, let me say, if let, okay, entry is this, then we return some entry, and this should be, let's convert this to a match because I want to handle the error case. Okay, so I'm just, for argument's sake, going to do and I need quotes there, and we'll say none. So it's just going to print out, hello, okay. It's just going to print out what the error was. Entry failed to read. And maybe what we'll find is that we have a bug inside entry read because we changed it, or it's in here somewhere. And I would love to see, if that is the case, what that is, rather than just returning none. The other option is we can go up higher, and no, that's actually the correct place in the entry iterator. Okay, let's run the tests again and see what we got. And so on these failed tests, it'll print out any standard error lines. Right. Okay, so we got unexpected EOF, failed to fill whole buffer. Okay. So that was a good thing to find. So it reached the point at which um, or rather so it had unexpected EOF. It means try to read past the end of the file, or it tried to read from our block contents reader. There is a thing here that we may need to deal with, and I think it's in here. I'm going to print out okay, we're going to do buff.len. Right, so this is going to say this is how much the caller wants. And then how much do we have left? Right? Because what we probably want to do for some safety here, it's possible for this to request more bytes than are left in the contents of the block, just by virtue of its length. So we need to, when we go to file.read, we need to shrink this slice to the minimum of its length, or however many bytes are remaining in this block. I would guess that we are, again, trying to read past the end of the file, or we're running over the end of a block. But given this message, unexpected UF, failed to fill whole buffer, tells me that it's trying to consume too much. And we're somehow artificially limiting it. All right, well, let's print that out and see what happens in those tests. Okay, let's see. So, yeah, so in this first failed test, we have 18 bytes, it tries to read 1. We have 18 bytes, it tries to read 1. We have 17 bytes, it tries to read 8. We have 9 bytes, and it tries to read 13. Right, so so this is kind of exactly where I expected it to fail. And there, it's doing it again, right? Why it tries to read that specific amount is kind of interesting. Let's go to the implementation of read for entry. And I think that we'll learn some things there. So, okay, so here it's trying to read 8, right? So this is the read the tag end. I don't know why it's reading it twice, but oh well. And then it reads 8, which is the header of the entry. Okay. So we didn't get the unexpected in a file here. So then we're getting the length and the CRC. So the length is telling, I'm thinking this is it. The length is telling us it is 13 bytes. Okay, and this is, Hi, Chris. Good to see you. I saw your stuff, or at least I haven't watched it yet, but I did see the Bevy 0.15 came out. Really exciting stuff in there. I might get back into that soon. I bet you're pretty excited too. Great stuff in that release. Okay, so we're trying to read. We're at this point, likely, right? We're trying to read 13 bytes, but we have 9 left. Now, one thing that's not clear to me is we're trying to probably read 13 compressed bytes, and there's only 9 left in the block. Yeah, I considered doing Advent of Code as well, Chris, but I did not. I decided not to do that. I don't need the stress of keeping up with it every day. Okay, so we have, the thing is here, it's uncompressed. None of these tests exercise compression. So we should be getting the same number of bytes as are in the as are in the contents of the block. Now, what might have happened is that when we're constructing this, I think it's this, right? Because our block length, and I don't have arc open. We're gonna open arc and hope it didn't. Oh, jeez. All of the stuff is broken since I upgraded. Reminder, kids, do not upgrade your operating system right before. And I have no idea what this is going to open to, so bear with me for a second. It might open to some video I was watching yesterday. Okay. No, stop. Archive all those tabs, thank you. Whew. We are having a great time today, folks. Okay, so in the HanoiDB design diagram, which we followed as well as the code, right, so each block, the block length includes the level and then the tree node data. The tree node data starts with this compression 1 byte flag, and then this data is compressed. So self.start is where this starts. So we're off by 4, which makes sense that that is 4 bytes short. There's our answer. It's funny how these things, like these tiny little computations, just propagate all over. Let's see if we run the test, if it fails now. Still fails. I think we're getting different ones failing, or it's just reordering the tests. Okay. So at least here, it's reading the last 13 bytes, and we have 13 bytes left. I think it's our boundary condition now. So I think, because if we want to read 1 byte, if our start point is that, we haven't read that byte yet, I think this needs to be just greater than. Because if we start at that byte, we want to be able to read it. We read the byte now, and we add the length. Now start is greater than end. But if it's equal, then we can't read that last byte. So let's try this again. Haha. Things are passing. That's good to see. Okay, we got one that failed. Invalid compression 118. So we still got some potential problems there. And I don't see any printouts on that test. So let's go. First of all, I think we should remove these ePrint lines we just did. Right in here. Let's actually just revert this entire. Thank you, Zed, for adding these features. Very nice. We'll revert that entire thing and then, oops. Okay. So we are going to look at our tests of the public API. And this was lots of entries. Okay, so called result unwrap on error value invalid compression. So we got our error invalid compression. So it somehow read a 118, which to me that looks like, you know, that's a ASCII byte probably. That's interesting. All the other tests succeeded. Here, we're going to bring it back up down here. Let's run it one more time and see if it provokes. The same error. It does. Okay. So this is this is a bug that is only exposed when we've written lots of stuff, which is pretty interesting. I think what we should do real quick is make a commit. And we're going to say this is session 18, affix boundary conditions of a block contents reader. Okay. Yeah, go ahead and push. Did you not make a, oh, did I not commit that? Did LazyGit just blow away my commit? What? Or I didn't save it? What happened? Oh, that's something messed up. Did I not stash it? Oh, boo. For some reason. Okay. We're going to do that over manually because I messed something up in LazyGit and I don't know what it was. Okay, so we're going to say fix boundary conditions of block contents reader. Okay. So now I think we need to, I do want to fix the issue of big files, because like that is the point of this kind of database, is you write lots and lots and lots and lots and lots of keys. And if we're hitting a problem at a small number of keys, I want to change this to expect. It takes a string. Could not insert key. Why don't we just give it the number, because that's copy, and then we don't have to worry about. That's just Clippy. Use of expect followed by a function call. Okay, well, the thing is I want that to be part of the error, so I'm going to ignore that. I'll put an explicit ignore on that in a minute, because this is a test. What I'm looking for here is there some specific iteration that fails? Which might indicate something in the background, like the incremental merges. 2047, that's interesting. So at this point, we've triggered some incremental merges that caused it to read a file incorrectly. That is really curious. Okay. Okay. So note that the result here either comes from adding it to the nursery, which is very unlikely to fail. We'll go look at that in a minute. Or it's from handle commands, which is all about merging. And if I had to guess, it's that we tried to read a compression field where there's something else existed. Let's go back to here. I think that won't change anything. Right, so we're getting this. So somewhere it went here and it read the seventh byte and got 118. Did we do something wrong on the writer side? Let's have a look. Because we remember we changed this to write compressed stuff. +2. Okay, we have an off by 1. Why is that? Because, and I'll bump this up. Sorry, folks. The block is structured such that you have the length at the head. So 4 bytes for the length, 2 bytes for the level. So that's where we get our +2 here. But the problem is block length bytes includes that, but also compression. The compressed data is 1 byte less than that. So we need compressed len +3 here. I wish there were a way to do this more formally. I guess we could go the route of let's make blocks something that we can use with Serday and use some kind of Serday protocol. Not protocol is not the right word, but a Serday encoding to write the contents. We still would need to do some of this stuff. All right. Let's make sure I didn't break everything with that change. And hopefully what we get is that when we're writing all of the big tests, or like the really long one, that it continues and it doesn't blow up. Remember, we had to change that last time because we weren't based on just the encoded length. It still fails at that same thing. Okay, so that was not the problem. That is interesting, though, that it didn't affect. Interesting, we go compress.len +3 here. Right? I'm surprised I didn't see that. Okay, so I think the answer I need to do here is I'm doing this thing twice. So I need to do that. And then here, I'll say block len, right? And actually, I think we have, I think we have an error for this number conversion thing. No, not slice conversion. No. Okay. But that should cut down on some of the errors. So we're only doing this computation once, and then we write the header. We could potentially see this returns u8 const write all, makes a slice. Yeah, this is fine. Okay. That does. That's interesting. I wonder if we've got a problem there. Index file position. I wonder if we need to add 4 here. I think we would have seen this bug earlier, though. This has been around for a long time. Well, I've made that little change. Let's just run the tests again. I think we need to figure out a test other than this write tons of keys test that exhibits this problem. So I'm gonna, we know where this error is emitted. It's from the block. You know, from start or from start length. So I think what I want to do here is and we're just going to put that in there, and it's going to, you know, print out a lot of goop. Let's just focus this one test because we're not fine. There we go. We're going to see a lot of these because it's writing a lot of them. All right. The backtrace is not going to help. It didn't print. Maybe they needed to rebuild, and it didn't. It is really curious to me that this is the penultimate key. Or no, that is the last key. Because our loop is 0 to 2048, so this is the very last one. Okay, so we did get a printout. That block length is huge. That surely is not right. The level, definitely incorrect. So we're reading garbage data here for some reason. So we must, if we're reading garbage data, we must be writing garbage data. I don't know why I didn't see that printout before. Was it there? No. Okay. Well, we're reading garbage, so we must be creating garbage. Now, which tells me it's probably here in the writer. And this is getting triggered on merges, right? Because it can't. I wonder if we could do something like list the contents of the directory. Let's do that. Da, 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 da. So a reader returns a reader struct. Will you let me click here? We're gonna open dash. Okay, reader is just an iterator over entries. Dir entry. Okay, oops, I messed that up. Wow, really great typist today. Okay, so I'm going to, it is an iterator, so I'm going to map, and this is a dir entry. We're going to do dir entry dot, reader yields result. Okay, we'll do flat map. We'll do okay. And this will be the actual dir entry. File name to what I'm trying to do here is just get just print out or return a string, which is the contents of the files that are in the directory, so I can see what state the database is in. Okay, so we get OS string. We want to look in Rust. Join. Oh, Nightly, aren't you fun? here's what we're going to do. We're going to make use of the format macro, which will return strings. And we're just going to do that. Okay, I know I have problems there. Just trying to get a little bit of sanity here so I can read. Okay, it returns an OS. Is there a to stir? Yeah. I do to owned. What does that return for this? OS stirs versus regular stirs. Ugh. Okay, I have a new keyboard, folks. I am also messing that up. OS string. Or is it OS stir? What does this return? OS string. Into string. Why don't we do to string lossy? The cow will just be, will deref to the stir. So to string lossy. Okay. And then now we collect. Okay. That was way more complicated than it should have been. Okay, so rather than this expect, what I'm going to do is go on wrap or else. Yeah, I think I want unwrap or else. So remember, insert returns returns unit inside the success branch. So we need to do, oops, I keep hitting that button. It's very helpful, too helpful. Okay, so we need to, at the end, just return unit, which honestly means we don't return anything. So as long as we end our last thing with the semicolon, it's fine. So we're going to do any print line. And we're going to say could not insert key I because error. Okay. And then we're going to say directory contents and we'll do ls of dir. That was way more complicated than it should have been, but here we go. Because I want to see what the contents of that is before we bail. And actually the problem is going to be it'll pass now. Probably should do map error instead. Yeah, see, it passed now. So it didn't print anything out. So I should do map error. and just return error. And here we unwrap. Okay. Then this will panic and so forth. But we will have printed things out. Okay. All to get the contents of the dang directory. Okay, so we've got a nursery log. We've got an A file and a B file. So we're probably trying to trigger a merge. Again, I'm not used to this new keyboard yet. Okay, so let's look back at the writer. I still suspect it's in here, and it has to do with, if I had to guess, it has to do with computing the length of the block. After it's compressed. So that we're getting like an incorrect offset. The other thing here is that it could be that we are not advancing this correctly. The question in my mind, though, is why would that... I think we're going to have to go look at some of the changes on this file related to compression that we did last week, because I think that by moving things around, because I want to say that this was based on not this computation, but how big the entire buffer was that we wrote for the block. And what we did last time was split this into write the header, write the contents. Before I change that, well, heck, let's just change it and see what breaks. hello, car. Can I not invoke cargo test? What? Why is it trying to do that? Bye-bye. New one. Things changed. We as a programming strategy, yeah, like poke things and see what happens. So what's really interesting here is that none of this changed. Oh, and it passed. Oh, did we find the bug? Okay, so now that we found the bug, or what I think is the bug, let's see if we can figure out why or how we changed it previously that resulted in this being off. Yeah. The other thing that we could do here is rather than this, let's make a more future-proof one. Remember, this block length does not include the 4-byte length header. What if instead we future-proof this to any other changes and we go header.length plus compressed.length, and there's going to be a type error there because index file position is a U64. Because we know that header is going to be 7 bytes. We've written that. The compressed contents is going to be however many bytes. I like that better. And then it's not, oh, there's this magic number everywhere. And I wonder if we can say something about like this number 3 here. Yeah, it's something to think about. Okay, let's run the tests again and make sure that this passes. And then I think we should go look at the diffs from last time and see how we moved things around in there. Yes. Remember, kids, wee is a valid programming strategy. If you don't know what's wrong, poke at it. Okay. Okay. All right. I need to make sure when let's look at the diff first. So we're gonna go over here, and let's look at this diff that we did last week. Okay, we already fixed the bug in block. So let's go down to, and there's all the compression, entry. We're looking for writer. That was a nice cleanup last time. Having only one kind of iterator is better. Okay, so previously we said the buffer for the entire block is the size. So this is like how much we have the encoded block, the encoded entries, plus 8 for the headers. So that was including the tag end. Okay, because we need to prefix that. So then it's writing the block size plus 2 because we're including the level. Yeah, maybe even that was wrong. I don't know. But the important thing here is, look, we wrote to one buffer and then we checked the length of it. Versus here, we're like computing something. And I should have done compress.len plus header.len. And there may even still be a problem here because note that here we were using the same value for last node size and advancing. I'm sorry, over here. We're actually doing it like so. I think we need to look at the read side of that to make sure that this change that we're making, even though it passes the tests, that the change we're making is correct here. Because there's for me there's a little bit of suspicion that this conversion or this setting this here, because the purpose of this is when you create an inner node for this block, you're creating a posilon entry and it takes these two values and puts that into that posilon entry that goes into the inner block, so into the inner node of the tree. So what is that going to affect? That's going to affect the read side. If the block length is too long or too short, then our reads are going to become unaligned and we're going to have problems. So what we could do here, I think the way to resolve this is we've written 2048 keys. Let's read them back. And then if we get a problem, we'll do this again. So the database, so get returns a result option. Isn't that pleasant? We'll do this. Okay. That should probably exercise the entire stack, right? Because we've written 2048 keys. Let's read all 2048 keys. Because we make this test pretty damn long, but I am concerned. Let me put it that way. Yeah, it failed. So it got none. So I think we need to do... We can just do this. The only problem here is that I'm thinking what I want to do is like capture what we were expecting here. Can you do, does assert equal? Let's look at that macro real quick. Right, it takes this. Okay, so it takes a format. So this is what we'll do to get for key I. Yeah. Oh, for Pete's sake, can you reorder those? Here. Oh, that's the problem. It doesn't implement display. Here. We'll just do that. And then I'll put these back the way they were before. Okay, now what's wrong? Oh yeah, we need to remove the unwrap. I was about to do it there, but okay. I would like to. I expected to find key 0. Oh, that's fun. It can't even find the one that exists there. So I feel like my house of cards is falling down. I want to think about this from first principles and check that all of the places that we use these things operate on those same principles. So we're going to start from the trailer. Excuse me. Okay. So the trailer gives the position of the root block, which is not always the first block written, right? It's probably most likely the last block written. Okay. And root position is a U64. So that is... Okay. then we don't need to worry about that. Remember, it's a U64 because that's partly what the file API wants for seeking. Okay, so let's go. What should we look at? Let's look at tree. Okay, so it goes. So if we open a file from, or open a tree object from a file, it looks at the metadata and the length of the file, and then it reads the magic from the head of the file, which we expect to be our string HAN3. And if that succeeds, it tries to read the trailer. So if we go down to read trailer, this seeks to 12 bytes from the end. Okay. Which is interesting, which means, like, do we even use this? Okay, it's just a check. It checked that we wrote the root block position correctly. Okay, so then it reads the last 12 bytes. The root position is the trailing 8 bytes, and the length of the balloon filter is the 4 bytes before that. And then we get right. So we need to. It's seeking back. It's seeking the file back to read the balloon filter and the padding. So we're reading exactly the padding. If it's not all zeros, you know, we get corrupted file missing trailer padding. And then we are reading the bloom filter. Right. Okay. And then it's getting the trailer. Okay. So I think the problem again is block versus writer. Let's look at block. So let's assume first that we're reading the root block. So we have an absolute start. So I think the thing here is that in tree, we can do root block, which is just, I don't know what the length of the thing is, just jump to that block, its starting position, and read it and trust that it has the correct stuff. All the other ones use this position length because it's based on the entry that we put in there. So we know that these two things, which we'll look at the writer again in a minute, we know these two things come from the computation that's done in that when I go flush a block into the file, into the output file. Okay. Okay, so the block from start length versus block from start. Let's look at block again. We've been looking at this a lot, but I want to read it very carefully. Okay, so we seek to the start point in the file. We read the 7 bytes of the header, which 4 bytes are the block length. So this is where this value is coming from. The level, which is 2 bytes, and the compression, which is 1 byte. And we have this ePrint line in here, but we're not. We need to remove that eventually. Okay, and then the from start length, which is like you have a poslen entry in an internal node of the tree. We're reading start and length. These should become start and blocklen. Note here the length -4, which is sort of what we were doing in the other thing, because the length. Okay, so this function is expecting the length in the poslen entry. Oh boy. Is or does not include the length header. It does not include this 32-bit unsigned integer as bytes at the beginning of the block. No, the recorded block length here is 4 bytes shorter than this. Okay, so our writer is still incorrect. No, this is correct. Wait, is it? The written block length. Yeah, see, we're going. I think that for consistency's sake, we need to not be doing this subtraction. I think that the poslen entry should have the same value as whatever the block recorded. I think that makes sense. So I'm going to do, because otherwise it's just too confusing. Like we either treat the length prefix on the block as including itself, or we don't. Technically, the spec, as shown in the design diagram, does not include it, right? Which is typical for this sort of encoding where you have a length prefix. You don't include the length. You don't include the thing that contains the length in the total. It's like, how long is this thing? So I think the problem here is that we're expecting the poslen entry to include that. And I think that we just need to get rid of that. So let's fix that problem. Okay, and then in the writer we need to make sure that Right. Okay. So in the writer, the poslin entry is going to use the length of the compressed contents plus 3 for the level and the compression. I think that's correct because I think if they line up, this is just about how far we are into the file. Like, so where's the starting point that you seek to for this block? In that case, we have to include the extra 4 bytes. We're kind of faking it a bit here, but especially this magic 3. And at the very least, I'm going to put a comment on here that says block len equals 2 bytes level plus 1 byte compression plus length of compressed contents. At least then, like, I know why this magic number 3 is there. And I might even put it on the front so that how did I do that? There we go. Then it's, here, I'll even be more explicit. Let's be pedantic. 2 bytes level plus 1 byte compression plus the length of compressed contents. Okay. I'm good with that. And then this block len and the block len that we're writing to the poslin entry should be equal. I think that's the same way to go about it versus what we had before with this like magic subtract 4. No, we should be we should be reading, or we should be checking that those numbers are exactly the same, not that they're the same by some modification. And here, like this bit, I'm still worried about these magic numbers everywhere. Right? Like this should be 4 plus 2 plus 1. I know it's, again, it's being pedantic. Okay. And then here, let's be pedantic about this. End is start plus 4 bytes block len plus the value block len. And maybe it might even be worth making a little diagram, like making an ASCII diagram of this stuff, which honestly, I kind of wish it hadn't been like this. I wish compression had been here, right? I think that would make this diagram make more sense. And then this is only compressed data. Yeah. Okay. Um, Note the self start +4 in both of these, which to me says um, it's not exactly the best name for that. Um, Maybe we say, let's rename that symbol to block start without blocklen. Hmm. Let's rename that one more time. Start after blocklen. Okay. Um, Interestingly, like we could put this stuff into the block contents reader constructor. Like we could do new, and it takes a block and returns result self. That's probably a good idea. And then let's, yeah, we're gonna have to pull this stuff out. This is block.file.try_clone. This is block.start. This is block.blocklen. And we need to do OK. Okay. Just like putting that initialization logic into something into something that like contains it. And then here, this is really about reading through the decompressor to get to get the entries out of it. Sorry. Okay, so it might make sense at some point to factor these out into constants, and then they can be like, like tag end here. They can be big, bright. This is what this means. So yeah, maybe I wonder if there's a code. No, there's not a code action on that. I was going to say, you know, it could extract into variable, but actually I want to extract into a constant. So, all right, I made a bunch of changes. Let's run the tests. And I hope that this actually fixes it, because what we really changed here was this. We expect that the length is equal to block len, and in the writer, we're using the length of the non-block len stuff into that. So now that those line up, then the test should pass. And let's just run all of them, not just that integration test. If it still fails, we're going to have to dig deeper. Okay, it passes. So now let's look at the diff, and also here, this is actually really easy to fix. We just get rid of that. Okay. What changes do we make over here? Oh, thank you. The scroll bar is showing me. Okay, so we changed this. What was the diff there? Right, okay, so we factored out this block length computation. We removed this one, so we moved it up and changed how it works. And then we are computing the offset into the file from the total amount that we wrote, rather than the block len, which is wrong. Okay, I think this is good. Let's really quickly, and hopefully I don't mess things up in LazyGit, but let's really quickly look over the changes. Why does it still show that print line? Oh, I didn't save. Helps if I save. Okay. Okay. Okay, and we moved the block contents reader. We removed that, all that stuff about constructing it into a function that we can call. That's good. Okay. Let's look at writer. So writer, we moved the computation of the block len field up above, so we're not doing it twice. And we documented it. That helps. And then right, and it got removed from there, and then we updated the file position to be correct, so we're not getting incorrect offsets, unaligned offsets into the file. Okay, and then we made that test a lot better, so that's good. Okay, so we are going to this is fix use and computation of block len to be consistent with each other. Okay. Okay, and we are pushed up. So since I started late and we had some technical difficulties, I'm going to continue to the top of the hour. I don't normally, but we'll go for another half hour or up to, depending on how far we get. Now that we've fixed the bugs, let's go make some new ones. I'm kidding. What we want to do is, you know, this, I think we can remove this allow. what we want to do is allow you to set the compression for writes. So we might do I was thinking we might do something like a builder of some sort. The other thing that is because what I don't want is like open with min and max levels, open with compression and min and max levels. The other possibility is that we make some options. Like as a struct, as a public struct. Something like we'll call it like HanoiDB open options. Similar to how you have like file open options. And then maybe these shortcut things just construct this, and then we make the primary one use this option struct. So we'll say pub, and then you could construct this yourself. I don't know, how do people feel about how do people feel about this sort of pattern versus lots of constructors? Okay, so yeah, I know it's never constructed. We're going to pub use compression because we're going to need that exposed, right? So people need to be able to make this thing. Excuse me. Okay, so let's take this one, like the body of this. At some points it's a builder, right, with all the optional fields. Yeah. So maybe what we do is we go and let's make this a builder. That's pretty good, I think. Okay, so let's say new. And this takes path P. say self, path, min level, none, max level, none. I know that there are like people have made awesome macros for this, but and this returns self. And then we'll do with min level, and we'll return self. Now the other thing we could do here is instead of option, because we know what we want the defaults to be, these are just U32, and we implement default. I actually like that idea. So we'll do, instead of new, well, we can't implement default. We'll just put the defaults in here. Okay. And then we don't have to deal with the options. Self. Fine. This is a little tedious, but okay. So the options are a builder, and then what we can do here is go, we'll have a shortcut for this one, and then all the others you'll have to use the option struct. I think that's pretty reasonable. Now we could also do just say open, which takes self and returns result of HanoiDB. Haha, that's pretty nice. And then we can say HanoiDB with options self, and we'll convert this one into use this options. That's pretty nice. So here we'll do, rather than this, we'll say HanoiDB open options, new, path, open. Okay, cool. And then we'll say here, let's change this. And we'll want to document this. Meant these things. Interestingly, I don't think we need these to be public anymore if we're doing the builder. So, I mean, I guess they can be. We'll probably want to also make sure that when we go to open this, that you don't have things like max level is less than min level, that sort of stuff. Yeah. Okay, so we need to do opens a directory as a HanoiDB instance with the given options. So we're kind of starting at this from the outside. That's okay. We're going to say we're going to rename this with options. And this is going to take options. And I'm going to have to put a generic on this. Okay. So what we can do here, get rid of that. And we can say path is options dot path as rev2 buff path buff, and this is options dot min level, options dot max level. Right, and so then let's see, options dot min level. Then the honestly, here, let me undo those changes, and we will go we'll just destructure that. And we're not handling compression yet. Okay. All right, so now we need to add compression to the HanoiDB struct. And I'm gonna reorder some things here. Let's move this down. Okay. Okay. So let's go ahead and add compression here. And then we can expand it here and put it in here. Okay, so we have compression in there. Now we need to figure out how to thread that through. Nursery is going to need it because it has to write files that are compressed, right? And then every level is going to need it. So this is kind of a toxic property of this this change. But let's power through. We'll start with the nursery. So the nursery, it's going to get compression. Okay. And then down here in write internal, we don't compress the nursery data. But here's where we would thread in the compression on the writer. Note it has a compression field. Interesting, this oddly named one is the only constructor. Is it not? Yeah. I don't, oh, okay. So in the tests we faked it, right? Okay. Um, so we added this implementation just for the tests. That makes sense. Okay. So the question is, do we add it later or not? I think the answer is we put it here. And then over here in the nursery, we have to do self.compress compression. I may need to rename that field on the writer because that does not make me happy. That does not bring joy. Okay, so now the writer gets it threaded through the nursery, but we're gonna have to do the same on the level because the level constructs mergers, right? So here we go again. As like I said, this is kind of a toxic thing. I think what happened in the Erlang version is that we just kept this struct of the options around and just passed it around everywhere. I don't think that's strictly necessary, especially since these things need to take ownership. We can't say, you know, every time we try to do something, we have to pass through that compression. So now it's in the level. And then let's see. So the merger needs to get the compression. So we need to go into merger because every place that it's going to, oh, wow, lots of tests there. Yeah, so it needs to know the compression as well. And luckily it only has to do it here. And then we go back to the level and we pass along the compression. Okay. So now we need to fix this place. Here it's using compression none. Interesting thing here is we should do this. We didn't have to strictly, but I think that's probably good for later ergonomics. So technically here we could write default, which would be fine. Okay, so now let's first of all run all that. Let's check our warnings here. We probably got lots. Oh, that was not supposed to be added there. Yeah, so we need to fix some tests, it looks like. Fun how we can do that. Okay, here's the next spot. Okay. And another one. just keep going down the list. You know, it is okay, a little tedious to deal with this, but it is nice. Interesting. This is in the nursery. So recovery, we didn't think about recovery, right? So in recovery, we need to pass through the compression as well. Because it's required when constructing the writer. Okay. So here we got a problem in our test. We'll just use no compression. My point here is let's go and like fix all the places, and then let's add tests that change the compression. So, and again, and as long as we're not getting to have too many arguments, it's fine to have this. Let me copy just that. And yeah, it looks like we'll be able to wrap up at the top of the hour, I hope. We will write one test and then we will go on with our lives. Okay, so here's a new bug. We weren't passing compression to level. Thank you, type checker. Here as well. I need to pass it to nursery. And one warning. What's the warning? It thinks it's not using that. That's interesting. That says to me that it really only matters at construction time, because now we put the compression on all of the child objects or child structs, like the levels and the nursery, and they keep it around. So maybe we don't need to. Maybe we just pass it in as an option and then it's applied to everything. I guess that's okay. And now we're clean as far as the compiler is concerned. So let's go and let's do a compressed round trip, right? I'm being a little bit pedantic here. This needs return result self. Okay, so now we can let's make a compressed for each one. So let's make it real quick. We're going to copy this. Let's see, snappy round trip. Okay, we're going to say with compression, and we're going to use compression snappy. Okay, and then we can sort of do the same thing for gzip and LZ4. And I hope we don't find bugs, but we might. One other thing occurs to me now that we're exposing this compression thing, is I think we need to do non-exhaustive. This will say that we can add variants to this later, and ensure that we don't break things in people's APIs. Because maybe we later want to add, I don't know, like Z standard or something. All right. Let's make sure we can compile. Okay. Let's run them tests. Okay, so Snappy failed. That's interesting. gzip worked. LZ4 worked. So there's something wrong with our Snappy tests. Ooh. Stream header byte for, oh, okay. That's interesting. Let's dig into that test. Okay, so line 285. Okay, so after it has written the file, it doesn't find it. But the problem is we get an IO error. We're gonna have to look at the Snappy library to figure out what this error is. So let's do that. It's snap. Okay. Docs.rs snap. And our text size is too small for the stream. Okay, so there's an error. And what did we get? Stream header? Says this error occurs when the stream header chunk type was expected but got a different chunk type. This error only occurs when reading a snappy frame formatted stream. So there might be a disconnect between how we're writing and how we're reading. And I seem to remember something about this. So let's look here. Snappy, we're doing raw encoder new compress vec. And we do frame decoder. So this is potentially not the same way. Because we did raw. I think the raw one, yeah. So we used the raw encoder and then we tried to use the frame decoder. So I think we need frame encoder. Which basically puts it into a similar pattern as gzip and LZ4, which is not that surprising. Well, without changing this API, let's fix that. So we're gonna comment that out because I want to be able to see what we did before. So this is wait, that's not what we want. We want something similar to this, right? Okay. Oops. New. Right, because we're not. Now here it's complaining we don't convert that, so we need to convert that error. Let's look at our error type. They say this is occurs when consuming an encoder fails. Let me say this is decompression error, right? And then we'll do from. Ooh, evacuate. Okay. Oh, I need a comma there. Yeah, it doesn't like this still. So let's go back here. Into inner returns the writer, or into inner error frame encoder. So this is actually what we need. Frame encoder W. That's an ugly type, but we'll just go with it for now. And W is hello. Okay. I need another. So many angle brackets. So this is snap. Right. Frame encoder. Okay, now what? Large difference between variants. Okay. Oh, why does it pass the writer through? We'll box that. This is that is a really strange API. So this into inner error contains the writer. So it failed. Okay, actually, we need to back it up here a second. I think what we need to do, rather than having this crazy construction here, is it failed. It's leaving. It's taking the ball home with it. Exactly. Exactly, Chris. You got it. I want a different way here. So I think what we can do is, instead of just relying on this, We can do map error, and we can. So this is the internal error. What we can do is call this, because this is into inner error. We can call this and get like into error, and then we can construct our own variant there. Note that this error, although it like bumped it down, is standard IO error. Okay. I honestly don't know how this could fail over a vec. But what we're gonna do is go snappy compression, and we're gonna change this to, we're gonna not have from. We don't want to auto derive it, right? But what we want is standard IO error. And then we will explicitly, let's go back here. We will explicitly go error into error. And then we don't need to wrap this in OK because we are returning the right result type. Okay. So I don't like this. I think, though, we already have something for standard IO error in here. I would be surprised if we didn't. Yeah, we had IO, right? But like, I think it's important to show that this is about, specifically about snappy compression. All right. Hey, the snappy round trip passed. This is good. Okay, and now it is well beyond time, but I want to do one more thing, which is, we've got the public API here. I think it's worth doing something with the options that we now expose. So we created this open options struct, and I'm going to rename it. It's fine. The problem is down here. We use somewhere down here. We use file open options. Yeah, let's rename this open options and see what happens. No errors. Okay, so we're not doing that in this file. That looks a little bit less ugly. Okay, so what I wanted to do here is in the public API. I don't think we have any tests down here. No. In the public API, I want to test, I don't know, a whole database with compression or something. Let's say open create database with compression. Okay, and then we're going to do we need open options. Okay. We're going to say open options, new, dir. Did I not? Here's the problem. I didn't expose it. Now, I probably could have like a prelude module, yada, 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 but honestly, in the lib, file here is fine. We are not. Yeah. Okay. So let's say with compression, we're going to use HanoiDB star there. Let's do LZ4. I don't know. Say options. Thank you for suggesting the builder syntax, Chris, if you're still here. Okay, so now we can do something like we'll do this little loop again. Let's do a smaller amount than this one, but and there we go. So, I mean, it's not really it's not really a great test. I think that we could there are potential options here for, like, what if we did min level, max level, and so forth. I feel like that is not that important here. I really want to know, like, I feel like the compression thing is the most volatile part of this change. So let's just run all those tests. And if we come up with ones later in the building of this, then we can figure out what those should look like and exercise some of the bits that we haven't exercised yet. Okay, let's look at the diff real quick, make sure I didn't leak anything in. Okay, so we got rid of that dead code. We made sure there's a non-exhaustive and implements default. We fixed the snappy. Okay, so I actually kind of hate that the TUI responds to clicks. We're going to discard that line. We don't need to keep the comment in there. Okay. We need to write the documentation real quick. That'll be our last thing. And this won't take long, I promise. It's interesting, though, that you look at the file open options, and it doesn't include the path. It constructs the thing with all of your bits, and then you say .open and you give it the path. That's kind of interesting to me. Maybe we'll restructure that later, such that we give, like, path as the first argument. That might make it a little bit more flexible, and fewer generics is good. Okay, so okay, and when we do write a unit test, we can do something like check that the min levels is less than the max level. Excuse me. And then if we don't have the path in this open options, then we can implement default. And okay. Yeah, I think that's a good refactor for next time, is to make it look more like file, like standard IO file or standard file open options. Okay. Yeah, let's stage everything in DB, and let me just page through and make sure it makes sense. Yeah, because then this would be like with options, path, default, which is pretty nice. That would be better. Okay. Look at error. Okay, so we added the compression all the way through these things. And that really only affects the merger and level. We exposed all of that. And I really don't like how it joined those two things. I might want to edit that, but for now, we'll go with it. Honestly, there used to be, like, Rust format had options for organizing imports, and I don't know if that ever became stable. Because it was really nice for the brief moment that I used it. Things were really consistent. Okay, and so then we've just, put no compression, all these tests in the nursery and so forth. Okay, and then the writer. I really think we should rename this compress field. Let's go and do that real quick. That's easy. I don't know why it was called compress and not compression. And then down here we can rename that compression. That's a little cleaner. Yeah. Cool. This is great. I'm sorry for the technical difficulties at the beginning of the stream. Let's go ahead and commit this. Plum. Let's see, add open options and plum compression setting through the instance. Yeah. I didn't push yet, so we just amend that commit. Yep. Okay. This is a great stream. Thank you all for hanging on through the extra length and for the first few minutes when I was muted because I didn't have my microphone plugged in and I was just all discombobulated. Thank you for coming. And I'm not sure what we'll do next time. Maybe we'll start a new project. Maybe we'll continue enhancing this. We still haven't done folds, which are really interesting for if you want to do scans. Um, we'll need to figure that out. You know, and part of the point of HanoiDB is that you have it's ordered on disk, right? So you could conceivably scan the entire database for keys matching something. So um, that's pretty cool. Anyway, we will see you next time, I hope, and I hope you all are enjoying Advent of Code. And not sure if I'll do any of it this year, but it is that time of year. Anyway,